when we look at problems like this, sometimes we're going to run into some difficulties because this is where we have chain rule. So we need to be a little bit more mindful of what we're doing when we have chain rule. We need to remind ourselves about chain rule. So we have chain rule. Derivative of f of g of x is equal to f prime of g of x times g prime of x. So when we look at this derivative, we want to find f of g of x. That's our goal. So when we take the integral, that's what we want, f of g of x. But a lot of times what we are given is a little bit different. So when we look at this, what this really is f prime of g of x. So what we need to decide is what g of x is. When I look at this, g of x is equal to 3x plus 5. And if I want to find a g prime, that means I am finding the derivative. So 3. So 3 is what we are missing. So in order to put this into our problem, we need to multiply by a special form of 1. We can't just multiply by 3, we have to multiply by a form of 1. So if I want to add in 3, we're going to multiply by 3, but also multiply by 1/3. This way I'm multiplying by 1, but then I also get the 3 that I want. So this integral is the exact same thing as if we took the integral of cosine of 3x plus 5, but then we multiplied it by 3 and 1/3. Well, we don't really care about the 1/3, so we're going to move that all the way up front. So what we have now is this is f prime of g of x. This is g prime of x. So now we can kind of ignore the g prime of x, and we just really need to take the antiderivative of cosine. So I have 1/3. The antiderivative of cosine is sine of 3x plus 5, because that g of x still needs to be inside, plus c. So the one thing here is if we were looking at this problem, we might forget the 1/3, the 1/3 coming from our chain rule here. This is not too bad, but when we're doing these problems, we are going to have things that are a little bit more complicated. This is where u substitution is going to be coming up.